Hi everyone, thanks for listening to my Module 5 squishy circuit experiment. I went through the engineer design process, and the first was the ask questions. So how do I create light using electrical circuits? What materials do I need to build an electrical circuit? And how does this apply to the real world? So during the imagine phase, the thoughts of possible solutions, I thought about different designs that I could do. So I thought about different animals, a snail, a butterfly, and then I thought about doing a ship. So I did end up going with a butterfly in the end. Different materials that I could use. I added yarn, glitter, gems. I was trying to think of different things that I could add to improve the design process. And then I also thought about how the electricity exactly flows through this circuit to create the light. So my plan here, I used all the materials in the kit, and then I added yarn, glitter, gems, and I used a paper plate. And you can kind of see my sketch here of what I wanted my butterfly to look like using the LED, the conductive dough, the insulating dough, the battery pack, some of those essential pieces in order for the circuit to work. Creating, you can see my steps of my process here. The first time I did it, you can see that only one of my lights worked. So I went back for my improve and modify to research a little bit more, and I found that I needed to add more insulating dough underneath the butterfly's head just to allow that circuit to flow to both lights. I also switched the light colors out because I felt like the red lights were easier to see when I was taking my picture than the yellow lights. And I said next time I could maybe try to also put the eyes as lights and to see how that would work with all four going. What I found successful was I did like my overall design and the things that I added to kind of make it a little bit nicer looking. And both the lights did work after modification. So moving on to the 5.1 STEM lesson specification, going through 1 through 11 there, you can see all went in the yes category. So does this lesson present a real problem? Absolutely. This is something that students will face every day throughout the rest of their life, electricity, so it's important for them to understand. It also, you can see for number 2, will students relate to the problem? Yes, because this is something, again, that they're faced with every day and something that really impacts society as a whole. Does the lesson allow for multiple accessible and creative approaches? Yes, because you could use different materials. Students would just have to realize that they would need certain materials in order for the circuit to flow, but they could use multiple materials in addition, and there's no right answer or correct way to do this. Does the lesson integrate and apply the importance of science and math? Yes, this is geared towards a second, third grade classroom since I'm in special ed, and so that fits in perfectly with our circuit science curriculum, and math would be tied into geometry with the shapes and creating that. Number 5, does the lesson clearly use the engineer design process? Yes, because I used it in order to create it. And so I think having the students plan and problem solve, create and improve and modify their design is really helpful. 6, does the lesson use student-centered hands-on teaching? Yes, the entire kit is very hands-on. Students would love to use the Play-Doh and kind of come up with different approaches to this activity. 7, does the lesson lead to design and development of model? Yes, they're creating a model. They could create a bug, they could create a ship, anything that they want to. Is the role of technology in the lesson clear to students? Yes, they would have access to their iPads and computers in order to research ideas, and they would also be able to then um, use it to help them improve and modify their design as well. Does the lesson successfully engage students? Yes, in purposeful teamwork. Yes, students would be in groups and they would be learning from each other and again, modifying and bouncing ideas and communicating in order to be successful. Does the lesson include testing and solution and evaluating results? Yes, students would have to, again, improve and modify and create as they go along. And does the lesson involve students in communicating their design and results? Yes, I would have the students then at the very end kind of walk around the room like a science fair and give each other feedback and communicate what was successful and helpful and what needed to be tweaked. Thanks so much.